Okay, so addition, we have to represent our numbers in our tens and ones. So 35 we represent as 3 tens because we've got 3 tens there, and we've got 5 ones. So 1, 2, 3, 4, 5, and we can check that. So 10, 20, 30, 31, 32, 33, 34, 35. We're going to add 13, which we can see is 1 10 and 3 ones. And then all we have to do then is count up our tens and then our ones. So we've got 10, 20, 30, 40, 10, 20, 30, 40, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, and then we can calculate our answer. 10, 20, 30, 40, 41, 42, 43, 44, 45, 46, 47, 48, and there's our answer. To move into greater depth, we need to be able to regroup our answer when it bridges our 10. So 5 add 7 is more than 10. So we do the same thing, we represent our numbers. So we've got 3 tens, 10, 20, 30, 31, 32, 33, 34, 35. Add 27, 10, 20, 21, 22, 23, 24, 25, 26, 27. And then when we regroup, our tens are fine because we've got 3 tens and 2 tens, 10, 20, 30, 40, 50. But in this instance, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 ones. So we have to have a 10 and a 2 ones, because 12, we've got 1 10 and 2 1, so it's just easier to show. So if we calculate our answer now, we've got 10, 20, 30, 40, 50, 60, 61, 62. But the hardest thing there is the children understanding that 10 ones makes a 10. Subtraction is a very similar method. We still represent our number as our tens and ones. So 36 becomes 10, 20, 30, 31, 32, 33, 34, 35, 36. But instead of adding on additional tens and ones, we're going to take them away. So here we need to take away a 10 and 2 ones. So if you take away a 10, and on a whiteboard you can rub it out, but obviously children won't have a whiteboard in their SATs, so they will be able to cross it out, so doing our drawings. So if I take away my ones first, I can just cross them out, so I've taken away 2 ones, and I've taken away a 10 because I've got 1 10 and 2 ones, which leaves me with 2 tens and 4 ones, which I can write over here. So I've got 2 tens and 4 ones, which is 10, 20, 21, 22, 23, 24. And then to move into greater depth, children are going to have to be able to exchange, which is slightly harder because we've got 4 ones, but we need to take away 7 ones, which we know normally would give us a minus answer if they were on their own. So it's going to go below the 10. We have to bridge our 10 going backwards. So 34, we're going to do the same thing. We're going to represent our 3 tens. So 10, 20, 30, 31, 32, 33, 34. We'll begin by starting to take away our 7, but we've only got 4 ones. So the children need to understand that a 10 I can exchange for 10 ones. The fact that it has the same value means that they can then subtract the 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we can take away our 7 ones. So 1, 2, 3, 4, 5, 6, 7. And we need to take away our 10 because there's 10 in 17. So I can cross that out, which leaves us with a 10 and 1, 2, 3, 4, 5, 6, 7 ones. So we've got a 10, 1, 2, 3, 4, 5, 6, 7 ones, which is 17. There's our answer. Okay, so multiplication. We've got our number sentence as 3 times 2. It's the language that we use with the children. So for example, we could read this as 3 lots of 2. So if we were to read it as that, we've got 3 lots of 2. Well, I could say, well, I've got 1 lot of 2 here, or I've got another lot of 2 here, but I've only got 2 lots of 2 there. I need 3 lots of 2, and then the children can just add those up. So 1, 2, 3, 4, 5, 6. There's my answer. It's also 3 sets of 2. That's another language that we use, but we've got 1 set, 2 set, 3 sets, and then add them all up together. We also use the same language as almost division. We've got 3 groups of 2. There's a group, there's a group, there's a group, and they can do that using drawings, and that's absolutely fine for the methods that we use. This also turns into an array, and the children are familiar with arrays, so we could turn this into an array, and it's almost looking like an array at the minute. It's just setting it out in the format in which we would see it. So there's a 2, there's a 2, there's a 2. And in this array, it allows children to understand that not only is it 3 groups of 2, which is 3 times 2, which is 6, it also lets them see that there's 2 lots of 3, which just lets them understand that multiplication can be done either way. It's commutative. This also really underpins their understanding of the repeated addition in multiplication, and it comes through of looking at these groups of. So here we've got 2, we've also got 2 here, and we've also got 2 here. And the same thing happens that if I add them all together, 2 add 2 add 2, gives me the same answer as 6. So I've got 3 groups of 2, or 2 add 2 add 2. And similarly, the other way, we would see it as 3 add 3, which also gives me 6. Finally, we've got division. So we're going to use the same, very similar language to our multiplication. We're going to be sharing equally into groups. So at the minute we've got 10, that's where we're going to start. We've got 10 shared by or divided by 2. So the children understand that we need 2 groups because we are going to share 10 into 2 equal groups. And then it's a case of, they would have practical equipment to do this at first. So they might have 10 cubes, which they're going to practically share into groups. And they take it in turns of 1 in this box, 1 in this one, 1 in that one, 1 in this one, 1 in that one, until they've used all 10 of their cubes. So the children just have to draw their cubes or their representation of a cube. So they've got 10 at the minute. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the value of one of my groups is my answer. So 10 shared by 2, or 10 divided by 2, is 1, 2, 3, 4, 5. And to move into greater depth, children need to understand that sometimes it doesn't always share equally and what to do with those leftover pieces. We've got 11 shared by 2. Now, first of all, the greater depth children would have to be able to reason that can this be shared equally into 2, and they would be able to use their times table facts to understand that 2 can't be shared, or doesn't go into 11 using their times tables. We would have a leftover, we would have a remainder. So that using the same method as before, we would have our 2 groups, which the children would understand as it being equal, but not always equal. And what do we do when it wouldn't be equal? So they would share 11 into our 2 groups. So by doing that, we would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But then I've got 1 that if I put it into this one, so if I put it there, well, I've got 6 in this one, but 5 in that one. We can't do that because our groups need to be equal. So I would get rid of that one out of there to make them equal, and then I'd just put it on the outside. And again, my answer would be the value of one of my circles, but then I've also got some left over. So I would show or represent this in my answer as my answer being 5, because that's the value of my one circle, but then I've got remainder because I've got 1 left over. So I've got 5, remainder 1.